So now we're going to solve the problem, that is the problem number 5 from day 4. Count the number of subarrays with a given XOR. So what the problem states that we are given an array of integer and a integer b, and we have to find the number of subarrays having the bitwise XOR of the elements equals to b. So what we are given an array and an integer b, integer array a and an integer b, and we have to find the count of the subarrays that have the bitwise XOR operation value as 6 as b. Okay, so what we'll do, we'll find all the subarrays, and for those subarrays we'll find the value of the XOR operation, and if the value of the XOR operation equals to b, we'll increase our counter for the number of subarrays. Initially the number of subarrays are 0, and if we found the subarray with value of its XOR operation equals to b, we're going to increment our count, and at the end we're going to return it. And to find all the subarrays, we'll require order of n square approach. Order of n square time complexity will be required to find to perform XOR operation on all the subarrays, and to check whether the value of the XOR operation is equals to b, and at the end we'll return the answer. Okay, so time complexity is order of n square, space complexity is order of 1 because we do not require any auxiliary space. So can we optimize this approach? Yes, we can. So what's the optimized approach to solve this problem? What we can do, first look at the intuition to solve the problem. Let's suppose for this patch of an array, let's suppose what we are given in the above array is, what are the values in the above array? Let me zoom out. Let's the value, let go to the array. Four, 2, 2, 6, 4. So this is the given array. So let's suppose for this patch of an array, let's suppose for this patch of an array, the value is b. Okay, the value is, let's suppose b not b, let's suppose the value is y. Okay, and for this patch of the array, the value is k. For the XOR operation, this is the prefix XOR. For this patch of the array, the prefix XOR is y. For this patch, let's suppose from index 0 to 3, the value of the prefix XOR, that means when you perform prefix XOR on these array elements, it will return y, and if we perform the prefix XOR on this subarray, we will return b. Okay, and for this subarray, let's suppose we have k. So we can definitely write that b XOR k is equals to y, because these two subarray add to form the bigger subarray. So this is what we can write. We can also write k equals to y XOR. What this value states that if we can find the count of k, we can find the value of the subarray that has the value XOR, the value of the XOR operation as b. The same intuition that we applies in the subarray with sum 0, the same intuition is here. There we have to find the sum of the array elements. Here we have to perform the XOR operation. So if this is the bigger patch of the array that has the value of its XOR operation as y, and these are the two subarrays that combines to form the bigger patch, then we can write the XOR operation performed on both subarrays will result to the XOR operation of the whole subarray. And what else we can write using the property of the XOR? K equals to y XOR b, because if we perform XOR on b XOR on both sides, and what b XOR b is 0, we only return with k. K XOR b is our final answer. So if we can find the value of k, we can find the value of the k, we can return the value of the number of times the subarray with XOR operation b can be found. If we can find the count for the subarray with that XOR operation as k, we can find the subarrays with the XOR operation as b. It is as simple. So how we can solve it? Let's perform a try run over the algorithm. We have to maintain a hash map to solve this problem. Maintain a hash map. So what we'll do, we'll store the prefix XOR in the hash map, and we have to count and we have to store the count of the prefix XOR. Okay. At the first element, we start performing the prefix XOR. Let suppose x is the variable that help us to store the prefix XOR. So x XOR the current array element. The current array element is 4, and using the property of XOR, we can say a XOR 0 is equals to a, and a XOR a equals to 0. This is the basic property of XOR. So our current element is 4. What we can say? 4 0 XOR 4 is equals to 4. Now we look at the condition. What are the two conditions we can specify? First is the prefix sum equals to b. If this is the condition, we're gonna increment the count of the subarray found. Let's suppose initially our count is 0. We're gonna increment our count. Else, if the prefix sum XOR the value of b is found in the hash map, we're gonna increment our count with the number of count of the value, that is, let's suppose it is the value of y, the count of y that is present in the hash map. Okay, these are the two conditions. So we'll start iterating over the array. Our current element is 4, so it is our first element. 4 XOR 0 is equals to 4. Is 4 equals to 6? Because our b value in this case is 6. Is 4 equals to 6? No, it is not. Is 4 XOR b, that is 6, is present in the hash map? What is 4 XOR 6? That is basically 2. Is 2 present in the hash map? No, 2 is not present in the hash map because it is the first element. So what we gonna do? We gonna store the prefix XOR 4 with its count as 1. Now we'll move to the next element. What is the next element? 2. We'll perform XOR. We have performed the prefix XOR, and our current prefix XOR is 4. X is equals to 4. Now it perform 4 XOR 2. 4 is this, 2 is this, and we'll do bitwise. So our XOR value is 6. Is 6 equals to B? Yes, it is equals to B. We're gonna increment our count. Our count become equals to 1 because initially it is equals to 0. Our count become equals to 1. Okay. Our count become equals to 1. Now we also have to check one of the condition, that is y. We have to compute the value of y. 6 XOR 6, that is 0. Is 0 present in the hash map? No, it is not. Then what we'll do, we'll store the current prefix sum. We'll store the current prefix sum with its count. So the current prefix XOR is 6 with its count as 1. Now we'll move to the next element. Our prefix XOR become equals to 4. Our prefix XOR become equals to 4. Now we'll check if 4 equals to 6. No, it is not. Then we'll compute the value of y. So we'll compute the value of y. Y is equals to, what is the prefix XOR? 4 XOR 6. It will return as 2. Is 2 present in the hash map? No, it is not present in the hash map. So what we'll do, we'll store the current prefix sum, that is 4. We'll increment the currently stored XOR value, prefix XOR value. Then we'll move to the next element. Our next element is 6. We'll calculate the prefix XOR. Our prefix XOR 4 XOR 6. So 1 0 0 1 1 0. Our prefix XOR become equals to 2. Is 2 equals to 6? Because our B value is 6. Is 2 equals to 6? No, it is not equals to 6. And then we're gonna compute the value of y. We're gonna compute the value of y. It is equals to 2. Our current prefix XOR is 2 now. Current prefix XOR is 2. 2 XOR 6. It will return us 4. Yes, we can find 4 in the hash. So what we'll do, we will increment our count with the value that is present, the count with the count that is found in the hash map. So plus 2, our count become equals to 3. Okay, count become equals to 3. Now we'll store the prefix sum, current prefix XOR in the hash map. Our current prefix XOR is 2. We'll store with its count as 1. Then we'll move to the next element. Our next element is 4. We'll perform the prefix XOR, 2 XOR 4. It will give us 6. Now our current prefix XOR is 6. Is 6 equals to 6? Yes, 6 equals to 6. We're gonna increment our count by 1. Now count become equals to 4. We're gonna compute, is 6 XOR 6 present in the hash map? No, it is not present in the hash map. We store the current prefix sum, current prefix XOR, that is equals to 6. If it's previously stored, we're gonna increment the count. Now we move to the next element. We have traversed the whole array, so we'll return the value of the count. Our count value is 4. Okay, so now we'll look at the code. So what the code states. So at the starting, what we'll have, we'll maintain an unordered map to store the prefix XOR, store the prefix XOR and its count. Okay, we'll iterate over the array. This is the variable that is used to calculate the prefix XOR. For every array element, we calculate the prefix XOR. We're gonna compute with the value of p. If it equals to p, it is the counter. It is our answer that counts the number of subarray with the given XOR. If our current prefix XOR equals to p, we're gonna increment our counter. Then what we're gonna do, we're gonna compute the value of y, that is equals to the prefix XOR and XOR of p. And we want to check if it is present in the hash map. We want to increment our count with the value, with the count, that count of the value of y, and at the end we want to store the prefix XOR in the hash map. Okay, at the end we want to return the count. So what we will do, we'll test our code, then we're going to submit. So we have passed all the test cases. So this is how we solve the problem subarray with the given sum. If you have any doubt, feel free to ask. And this is just an extension to the problem subarray with sum 0. If you have understand the concept of subarray with sum 0, you will surely gonna understand this problem. Thank you.